I first want to start by thanking the creators of the Building Performance Interactive program, and that's both Hugh Wierisky and Yulia Potor of Partel have created this program with us and have worked tirelessly to produce the videos and the programming that go into this series every month. So thank you, Hugh and Yulia. And Yulia, if you wanted to say a few words, we'd love to have you do that.
Thank you, Zach. Thank you very much. Hi, everyone. I'm Yulia Potor, Marketing Manager at Partel. I think this episode is timely, that it's on the eve of Earth Day and could be dedicated to low carbon future. So far, the co-hosts and the guests have addressed the needs, benefits, and projects related to offsite and modular construction based on timber frame. What's interesting about today's episode is the new approach related to the sustainability of the LGS structures. I'm looking forward to hearing about this.
Thanks, Yulia. So I'm going to be playing the role of Q&A concierge today. So as questions occur to you, please type them into chat. I'll be tracking those. And when it comes time to get to the discussion session, I'll invite you to come on screen and ask your question of the presenter and the co-hosts. So speaking of the co-hosts, I'd like to introduce them. We have Ben Adam Smith of House Planning Help, Mike Jacob of Kiss House, and Hugh Wierisky of Partel. So co-hosts, please take it away.
Yeah, as mentioned, I'm Ben Adam Smith from House Planning Help, where we focus on building high performance homes with low embodied carbon. And I must admit, our topic today is not one that I know much about. And having seen probably not a light gauge steel project, but a steel house being put up in our village and watching the frame go up and thinking, why on earth have you chosen this route? I'm interested to see what the differences are for a light gauge system. And if you've been looking at the promotional material as well for this episode, is that the form of the building? So I'm sure all will be revealed in a few moments. I'll hand you to Mike.
Hi everyone, my name is Mike Jacob. I'm one of the co-founders of Kiss House. I'm really excited to be here today. I'm expecting to learn a lot about the weight benefits in particular of LGS and some of the what to some might be counterintuitive or at least surprising, but no less exciting sustainability credentials, especially with the way steel manufacturing is going. So I'm really looking forward to hearing Paddy's presentation. Thanks very much. Over to you, Hugh.
Thanks, Mike. Yeah, so my name is Hugh Wierisky. I'm a director at Partel. So yeah, again, looking forward to getting into the detail with the LGS. I know in some regions it's quite well developed already, but we see in Ireland it's growing really quickly right now. And it's an important system for everyone to understand and experience. So for today, we're really fortunate and very happy to introduce you to Paddy Mahon. He's the head of design and engineering at Framespace Solutions. Paddy has worked for tier 1 main contractors in Ireland and overseas, and he now heads up the Framespace design and engineering department. He's a highly motivated master's qualified engineer with a proven track record in delivering complex projects. Paddy and his company at Framespace are very much at the forefront of cutting edge offsite solutions with a clear focus on light gauge steel assemblies. So over to you, Paddy.
That's a hard introduction to follow, but very much you. Look, I'd just like to say thanks to everyone involved for the opportunity to take part today. I think there's a video coming up that'll just go through the Leitrim Village project, so we'll roll that and we'll catch up a bit more after that.
Hi, my name is Paddy Mahon. I'm the head of design and engineering with Framespace Solutions. So today we're here at Drumhierny Hideaway Lodges in Leitrim Village, County Leitrim, which is in the northwest of Ireland. We are currently building 16 lodges here that'll be used for short-term breaks and holiday getaways. This project was interesting to Framespace because it's a local project. The client wanted it to be open for this summer, which it will be, and just the design of some of these cabins posed a unique challenge to us that we were excited about being part of. So there's 4 different cabin types here, all of which have different roof profiles and different shapes. So it was the perfect opportunity to showcase what LGS can do, and in terms of not just a box shape that we're forming, and that they can actually be architecturally pleasing to look at also. A high level look at the process from getting from the design stage through to something at this point would be a client or a prospective client will come with their architectural plans. We will work through the job with their design team, with our own in-house design team, making sure that everything is compliant in terms of building regulations, be it fire, thermal, acoustics, etc. From there, we get to an architectural design freeze, and at that point, we get into steel detailing, coordinating models, and then eventually end up on the fabrication floor. So some of the challenges on this project, I suppose, were set out early days where the client had the requirement of not putting in a traditional foundation system. So we got into the nuts and bolts and came up with a pile solution, which is very different to anything we've done before as well. So something we had to work through how we do that from an offsite perspective as well. Some of the other challenges, there's a very unique looking building here that's in the full triangular shape. So that in itself was very different, but a great challenge to have to work through. And thirdly, I suppose the fact that they're raised buildings off piles, it was just working through that detail really, because it's quite unusual and something, you just have to work through and look at from all the different aspects just to ensure compliance with regulations, etc. We use lots of different foundation types, compatible with, traditional raft solutions and more traditional solutions like that. And also what we tend to use a lot is an insulated raft solution. On this particular project, we got thrown a bit of a curveball in terms of there was no concrete wanted, and in terms of the layout of the landscape, it didn't really allow for that either. So we came up with this helical screw pile solution. So what we've got here is a number of helical screw piles throughout the footprint of the building. They vary from 2 to 3 meters into the ground. On top of that, then we created like a pile cap that's galvanized. From there, the floors sit on top of this and are fixed down and bolted to the pile cap. So the duration for installing one of these cabins, it varies from cabin to cabin depending on the type, but you'd be looking at something between 4 to 7 days between starting erection and having the building weathertight. Here at Framespace, we do a 2D panelized system, so all our panels go in 2D form. The externals are finished with windows and doors fitted wherever possible anyway. We do some 3D in terms of our roof volumetric units go to site in more of a 3D form, and maybe lift shafts or something like that we would consider doing off-site in a 3D form as well.
I'm Valentina Luján. I'm design coordinator here in Framespace. In Framespace, we have an in-house design team that it divides in 3 major teams. That is the architectural team, the steel detailing team, and the M&E that usually is a subcontractor. So the first input that we have is from the client, either from the architect's clients or the client themselves, that they bring us a drawing, usually a PDF sketch of the project or a fully designed job with planning permission. From there, we take on and we build a basic Revit model where we input all the difference that we need to adapt from the original design to be able to build it with our own system. We also put a bit of an input around Part L compliance, Part B compliance, Part K compliance, or general building regulations compliance. After that, we revert back to the client or the architect's client with the model and the difference that might have risen after that. And then we continue our steel detailing in-house. The steel detailing is done in Vertex, and from there we coordinate the Vertex steel frame model with the architectural Revit model in Navisworks. If we have a hot wall steel beams or joists, or in this case of Latrim, all the foundations, we also coordinate that other hot wall steel model with the other two, and the M&E. In Latrim, the M&E is very basic because they're cabins and they have 2 or 3 SBP, but in a building high-rise, we do a fully coordinated model with all of them. When we reach a design freeze stage with all the layouts and approved by the client and the architects, we extract the information from Vertex in an XML file, and we feed with that information directly the machines on the floor. We also extract from Vertex the panels layouts in 2D for the guys on the floor. This simplifies a lot the information that we give to the guys on the floor, so we don't need a very specialized team on the floor to read those drawings. On the floor, the stations are, each station has their own screen where they can actually pull out the drawings. We are a paperless office, and this allows us to have always the latest information showing on those screens. So if any drawing gets updated or any change has been done, they always see the latest information on the screens. Our system allows us to have several thickness of insulation. So depending on the client requirements or the architect's requirements, we work together with Part L to get the most cost-effective thickness. The Latrim project was categorized as non-domestic, but we can achieve any type of U value that the client requires. We have a full suite of thermal models of all our critical junctions, and for every specific job that we have a critical junction that we are not totally sure, we generate a new model.
My name is Darren McGowan. I'm a technical consultant in Part L. We do lots of work with Paddy and the team in Framespace in a number of different elements of the building. So we help with product specification. So for example, we help with breather membranes, weather defense membranes, and tapes and adhesives. We also supply structural installations, and we help out with, I guess, project-specific queries. So for example, as you've seen in the video already, the cabins on this project are raised up off the ground, and that raised some specific questions on, you know, what sort of membrane is used underneath those cabins, which is quite an interesting one. So we help with product supply, and we also help with, I guess, project-specific queries. We also help Framespace with the U-value calculations for their walls and roofs. So they work to many different specifications depending on client requirements, building regulations, and so on. So we can use our U-value calculation tool to optimize the amount of insulation and the insulation types that are used. So basically we optimize the performance, and we also work very closely with Framespace to make sure it makes sense financially. As well as this, we can work on a software called Woofy. That's a condensation risk analysis tool. Basically, once we get the layouts from the design team from Framespace, we get sections and building makeups, we can start to look at the risk of interstitial condensation in that build-up, and obviously help to design to avoid that.
Once the design is complete, the files go down to the floor for the guys to start manufacturing. We start at one end of the factory, so all the coils or all the steel comes in the form of coils that are slit to suit the different profiles that we do. So we do a number of different profiles at a number of different gauges, depending on the structural requirements of the job, or whether we're doing floor joists or rafters or whatever. So the coils are fed into our steel rolling machines, which that's where the NC files go. So that's the numerical data that tells the machine where different punches go and basically where the different connections are going to be. So the steel is fed through that machine, punches are done, and the profile is formed, and it comes out the other end in unique lengths to suit the wall or whatever panel it's going into. Each member has a unique QR code, so each member can be scanned for traceability in terms of who made that panel, what coil that came off of, all the way back to where that coil came from. So from there, the studs get sent to the framing station where frames are assembled, and from there they are moved along to the boarding and installation station. So at that point, a board is put on one side of the wall, turned over, the frame is fulfilled with insulation, and then the panel is closed up with another board. On the Leitrim Village project, there was two forms of insulation used. So the frame was fulfilled with a mineral wool insulation, and that was both for a thermal and a fire protection perspective. And then outside of that was a PIR board that was used to remove the coal bridge and improve the U value. Every project we do, air tightness is thought through at the initial design stage. So we think through the strategy that we're going to put in place to ensure we can achieve the best air tightness possible for the project. In this particular project, we have isotherm or Pertel's isotherm in the roof that comes down to meet our internal wall board, which gives us air tightness of that line. And then for the floor, we use Pertel's exotherm 150. On the Leitrim project, the building envelope was completed off-site, somewhere between 80 and 90%. So that included the cladding and the roof sheeting. We strive to complete as much as we can off-site, as much as is physically possible, to transport and ensure that the quality is, to the highest standard. Because anything we can do here could take 2 to 3 times longer on site. Some of the differences between our light gauge steel frame system and more traditional form of construction would be, I suppose, our system is designed out to a very finite amount of detail. So that gives you a great cost and program certainty, and de-risks it from a client perspective. In terms of efficiency, like waste-wise, we'd be operating at 1 or 2% in terms of steel and that. So from that perspective, again, you're just cutting down from that end of things. We also get a lot of time efficiencies in terms of, things are designed out fully, manufactured here, and then the installation on site is quite a quick process. So again, that cuts down prelims on site. All our guys are locally employed, so it means that they work here in a factory under a roof, which does help with the weather conditions we get here in Ireland. And they're working on big projects, say in Dublin, or 3 or 4 hours away from local to their own home, which allows them to go home to their families in the evening and not have a long drive. So we're a pretty young company, and in terms of embodied carbon, it's something we're working through at the moment and doing a lot of work on in the background, especially in current times. It's become a huge talking point and even a regulatory point, so it's something we're taking very seriously. So in terms of that, that's something we're working through. Just in terms of waste and that, though, I know from a steel perspective, we operate at wastage of between 1 and 2%. And we're very conscientious about recycling any insulation that's left over or off cuts. So there's a big scheme of recycling materials like that in the background in the factory as well. So in this particular project, the advantage of using light gauge steel were that it allowed us to manufacture a lot of the panels and the roofs off-site, and that gave a number of advantages overall. So in terms of speed of delivery, it allowed us to start design in October, start manufacturing in December, and the install, and have the site open for tourists this summer. Another advantage would be that finishing panels off-site allowed us, or ensured that we didn't create a huge building site in the middle of a forest and destroying all, the ecological habitats that are here. Thirdly, I think the certainty in terms of program and supply chain, especially in the current environment where there's a lack of certainty in cost and in the supply of materials and labour. My favourite part about working on this particular project would be working on a project that's close to home and is very, very, very unique and will be here for long times to come.
Presentation here that I'll share now. Okay. So this is a quick presentation on just who we are and what we do and just the process that are involved in that. So just agenda, what we'll cover today, we'll have a quick introduction, we'll go through our design processes and the design of the system itself, talk a bit about our certification, the manufacturing process, the installation process, and scalability both now and in the future. So just a bit about us. Framespace Solutions were set up in 2016. We're based in County Longford, Maryland, which is in the Midlands of the country. We specialise in the design and manufacture of light gauge steel building systems. So there's two lanes in this particular aspect. We act as both a specialist subcontractor where we supply the structure and the finished building envelope in terms of the externals will be finished, windows fitted, and you'd have an airtight, weathertight envelope. We also act as a main contractor, so we'd be offering a full turnkey solution on some of the bigger schemes that we're working on as well. Just some of the key benefits of LGS. So it's lightweight structure, its strength to weight ratio is very good. So there's a lot of efficiencies from that perspective. And with all our designs being fully engineered out, we'll always be working towards the most lean solution. So we'll in terms of centers of studs and in terms of the gauges. Because of that, we are able to get a very efficient foundation solution. So if we're going with some of the more traditional solutions in terms of raft slabs, you know, there's some very lean solutions that we've had in recent times where you're looking at slabs between 100 and 150 mil, which is very, very light in modern times anyway. Superior accuracy. So in terms of manufacturing, we'd be operating with our panels with an accuracy of plus or minus 1 mil. Durability wise, we, as part of our certification, we have a minimum design life of 60 years. And if the building envelope is maintained over those years, it'll definitely exceed that greatly. Design flexibility. So you can see the picture of the triangular building in Leitrim, but like HCU gives great flexibility in terms of the spans and shapes that can be achieved with a lightweight structure. It's inorganic, so again, with the steel frame, it's fully protected also within the envelope, so it's not going to suffer from that perspective. And there's no shrinkage or movement after it's landed on site and fixed in place. So what we do, steel frame or light gauge steel frame constructions are split into two approaches. There's the open panel approach, which is like a steel frame, maybe boarded on one side in some situations, and in others it's just left open. So that's just bare frame going to site being landed. You might see that in commercial buildings a lot where they're infilling into a concrete structure. And then there's the closed panel approach, which we embrace. So that has panels boarded both sides, insulated, air tightness tape put on wherever possible. And then the panels are joined on site. So obviously those elements are all sealed up from that perspective as well. So just some of the key considerations that have go into every design, but they also went into the development of our system itself. So in every job, as I said, a chartered engineer will engineer the full job out. So all the structure is seen through from one end to the other. And we come up with the most lean solution from that perspective. So just to keep the building as lightweight and as, lean in terms of steel as possible. In terms of fire, which is a big player in the market we're in some of the multi-occupancy buildings we do. So we've carried out a full suite of loaded fire tests. So that had a big influence on the board selection and the installation selection that we have on certain projects anyway. In terms of acoustics, we have a full suite of site and lab tests done on our wall and floor build-ups as well. So again, that had a big influence on the boarding and the installation types that we've used and selected. And then in terms of thermal and partel, so we've a lot of work done on modeling junctions and trying to gain efficiencies, but we'll talk a bit more about that in the following slides. So just looking at the design and build workflow. So as I was saying, structural engineering, thermal calculations, and the building regulations in general feed into our process at an early stage. So we ensure that we achieve an architectural design freeze with all of those thought about and fully worked through. We model every single job. So from an architectural perspective, we'll do a Revit model for every job. And that just allows us to coordinate the design all the way through the steel detailing, the M&E and the sheathing model. So all that feeds into the coordination model, and that can take a few rounds until we get full sign off. At that point, we create the production drawings and the assembly drawings, which go to the factory floor. And that's kind of bringing the information back to its most basic form and making it very easy for the guys on the floor to assemble and manufacture the panels. From there, we have a digitized scheduling and dispatch system here in the factory as well. So all the panels get loaded and are sent to the factory on a 40-foot trailer. And in terms of construction, then at the other end, it's digitized at the other end as well in terms of our quality control, and all our drawings are looked at on tablets on site. So looking a bit more at the Part L, or the fabric, the thermal end of things, the fabric energy performance. So with the steel frame, we have a warm frame envelope. So the steel frame is fully wrapped in insulation all the way around to prevent thermal bridging or cold bridging. We embrace the fabric first approach. So we'll work with the client on projects just when they're doing their initial Part-L calculations to ensure that they're getting the most efficient solution for whatever U value, or in terms of whatever M&E strategy they're going to have in place in terms of heating and ventilation. U values are generally driven by the client spec and building regulations, so we have great flexibility in terms of the thickness of insulation we can put on our wall panels as well. So just in terms of thermal efficiency then, as we touched on earlier on, we have a full suite of thermal models completed for all our critical junctions in 2D and 3D junctions, that is. So they feed into the BER, the initial Part-L calculations that are carried out. And there's huge efficiencies to be gained there in terms of using these thermal models as opposed to the default thermal bridging factor that will be within the software. Now, I'm probably getting very specific around Irish energy regulations, so apologies if that doesn't come across for others. So U values are adjusted to clients' requirements and to ensure Part-L compliance. And then we operate with an average air tightness of around 2 meters cubed per hour per meter squared. So it depends on the complexity of the project and, the form of the building. But, for some buildings, we've got down as low as 0.6. So it is possible. It's just we need to know at an early stage. And again, it just depends on the building itself. So we've carried out hydrothermal risk analysis. This is something Hugh and Darren, the guys at Part-L, have helped us out with. So we've done this for wall, roof, floor build-ups, just to ensure and give us confidence that there is no risk of condensation in our different elements. And you know, it just gives the clients great confidence in the system as well. Just in terms of digital workflows, touch on it again. So all our processes in terms of design are fully digitized, from workflows, sign-off points, all the way through to the factory floor, which we use a manufacturing software called Parsec. All our drawings go to the floor, and we have full traceability on all the different elements that go into our panels. And then all the way through to site, again, where we record everything on the construction cloud and carry out all our quality checks there. So lean manufacturing, so 3D modeling and coordination is used on all projects, no matter the size. Intelligent building models output data directly to the factory floor. So as drawings are updated, it goes to the floor. We have full digital traceability of all the workflows from the design office, factory floor, and site works. And this dramatically increases accuracy and efficiency of production and eliminates waste materials, resources, and time. So I just have a quick assembly preview, something that we carried out early days, just to have a look at the buildability of one of the triangular buildings in Leitrim Village. So I'll just play that now. That's that. So just a quick overview of, I suppose, the program upsides of using the like-edge steel frame system would be that, well, it kind of speaks for itself. The groundworks and foundations are ongoing while the design and manufacture of the superstructure are ongoing. So kind of gives the site a head start, and the install generally, it's very fast. There's a lot of work done in terms of building envelopes sealed up, windows fitted already. So it just allows the M&E and the fit out internally to crack on very, very quickly after the install. So just in terms of embodied carbon, this is something we're working on a lot at the moment. It's, you know, there's a massive shift in focus towards this. So we're doing a lot of work in the background in terms of trying to material mapping. We're developing a way of automatically calculating the embodied carbon in the buildings from the Revit models and the steel models that we're producing, because we have such certainty in the quantities of both all the materials that are used, so we can get a really good read on that. That's something that's being worked on in the background, but it's very exciting. We do see a real need for innovation and increased number of EPDs in Ireland. As I said, there is a real shift in focus to this now. I do believe it will take regulatory change, which is coming, for it to be fully embraced, but it's something we're working really hard on and trying to get ahead of now. In terms of increased ability to design disassembly, so this is something that again has come into focus and something we do think about, or have been thinking about anyway. So the Leitrim Village project is an interesting one from that perspective, because there's no reason why on that particular site, if the need may ever arise, that they could remove the screw piles out of the ground and return it to a brownfield site. And we touched on it earlier on, so we have a very low waste in terms of 1 to 2% of the steel, and that any of the waste steel actually gets recycled and made back into coils again. And the like-edge steel strength to weight ratio, as I say, gives massive efficiencies, ensures that it's a lightweight structure anyway. Just in terms of certification, we received our agreement cert from the National Standards Authority of Ireland back in January. So this certifies us to construct buildings up to 20 meters to the top floor. So, you know, that was a big moment for the company. and we have our CE in 1090 certified, and we're ISO 9001 certified also. So just in terms of scalability, we're operating out of a 120,000 square foot facility in Longford. We're utilising about 50% of that at the moment, with infrastructure for cranes, etc., put in place. We're very focused on a lean manufacturing process, so we've developed that in part of the factory that we're working within now, and we're currently producing about 3 to 5 units per week of varying complexity and size. There's plans to increase this to 500 units in the next year and grow to 1,000 units per annum by 2025, which will obviously require investment and the infrastructure put in place in the rest of the factory. So that's currently ongoing. At this point, I'd just like to say thank you. That's the end of the presentation. So I'd invite some Q&A at this point.
Yeah, Paddy, that was very impressive. And I think your focus on lean solutions for steel is a really good idea. Just looking at what you've built up, I think I'm right in saying that you started all this in 2016, and 8 years on, just looks incredible how much the business must have developed. And I like, some of the efficiencies and the piling. That's always a foundation system that I've thought of as a good idea. Particularly, it looked like that location was one that you'd want to preserve and not wreck what's in the ground. Steel it's a really useful material. We all like steel, but I suppose one of the questions I still have is specifying the right material in the right place. So I know you showed your embodied carbon slide and so forth, but there's a limited amount of steel. So one of the things I still hope to discover, as we have issues with materials and things at the moment, is that something that you're worried about in terms of the whole business model? It applies to all materials. I know that we're struggling, but
you're from an embodied carbon perspective,
just from I'm aware of an environmental impact. We're going to have to use all sorts of materials. We can't rely on any one thing. Simon says build like this, we all build like this, it goes wrong. Yeah. So we do need a balanced a variety of ways of building. Exactly. But yeah, just from your is steel, you can just keep on getting it, creating it, and the whole manufacturing process. How does it look from your perspective?
Yeah, there doesn't seem to be any issue in terms of availability. And I know that the plants that are, creating the coils and that, the technology is developing all the time as well for them to become more efficient. So like it's across the board, everyone has to move forward and take a step forward and try and, do their part to reduce the embodied carbon and ensure that each sector comes along with it, because there's no one solution for all. That's probably what I'd be getting at. But from our perspective, we're not really worried about it in terms of availability and where it's going. We know that it will definitely fall into place from that perspective.
Is there a sweet spot in where you might use it? Because going back to specifying the right material in the right place, in that woodland project, I might suspect that they go down a timber construction route. Yes. Sorry to say it, but I was looking at thinking, I can understand for concrete, for example. I'm not a big fan of concrete, but I fully understand there are situations when you're going into the ground and water and all the rest of it. And steel, I always think of for strength.
Yeah, so there's a couple of scenarios there. Just from the Leitrim Village project perspective, I think one of the things that really drove it was actually manufacturing the panels off-site. So using light gauge steel frame allowed us to clad the outside of it to within 90% of completion and have all the roofs, fully finished as well. So it was weather tight, instead of erecting scaffold and everything else that goes with that particular site. But that's that particular scenario. We're not that far away from that site either. But a sweet spot for us would be multi-occupancy, so like apartments where, you know, fire and sound regulations come into play as well. We, you know, as I said, we have a full suite of fire tests, and we can go up to 20 meters, which is a massive advantage. So that's, I suppose that's our sweet spot, and it probably lends itself in terms of shapes normally for apartment blocks as well. It just makes it a lot easier for manufacturing.
Hugh, what are your thoughts?
Yeah, thanks, Ben. I suppose in terms of takeaway, what I've experienced over the last couple of years, and in that presentation as well, is that I suppose LGS carries a lot of the same benefits as timber frame construction when it comes down to safety, waste reduction, speed, lower weight, and you know, that thing with the foundations is really interesting. But yeah, I do know that they lend themselves to higher buildings generally, so 4 stories and up, or 15 meters and up. And I had done my own research into the embodied carbon, and look, obviously it's highly variable depending on the structures, but it can be similar to timber frame depending on the building, when end of life is taken into account. So I suppose it can also be lower in some cases when insulated render systems are used, and LGS can lend itself towards that more so than timber frame. And but really, I see that the fire is the big driver in the higher buildings for this type of structure. But I do have a few things I wanted to get to push you for a little more detail on, Paddy. So kind of when you see full roofs being delivered like that, I'm wondering 2 things, I guess. Is there additional structure required for that? And from my past working on construction sites, how do you manage things like windows and, you know, to prevent any damage or movement? Or is that something that, you know, the LGS kind of helps with? And the last one, can you recycle the LGS?
So I'll start at the beginning with the roofs. So yeah, look, it's something we've worked really hard on developing, is the roof system that we have, because it just allows us to get a weather type building within a day. Really, once we get to wall level, you could land 20 of those roofs in a row. It's that simple. And you kind of work through the buildability of it as well. Like we have situations where we have vaulted ceilings and different things like that. So we'd end up with temporary braces in place for transport, just remove them and you have a vaulted ceiling. Whereas to construct that on site is, you know, it's very time consuming. It takes a very skilled tradesperson as well to do that, where we can achieve it here in the factory, you know, with general operatives. Just from a windows and doors perspective, yeah, that's one of the key benefits of LGS steel. You know, the structure itself, there's no added structure required. You know, the panel itself will hold square when being lifted. Windows are fixed back to the steel, and it just allows us to get all the air tightness and the weather seals completed in a factory setting, with the window reveals rendered, say on a render building or something like that, or in the Leitrim Village project, we had the cladding and the flashings put in place for that. And it does, on your last question in terms of recycling, yeah. So we, as I said, we have a big recycling scheme here. So any, you know, this very small offcuts of LGS steel generated when we're rolling. So they all get put in a skip and are sent for recycling and end up coming back to us at some point. I think anyway. So that's really, they do get recycled anyway. So that's,
yeah, that's really interesting. It's a huge thing to be able to manufacture to that level in the factory. So yeah, Mike, I'd love to see what you thought about that as someone who's closer to manufacture.
Yeah, thanks, Paddy. Thank you, Paddy. I enjoyed that. It was really interesting. I can see there are so many clear and arguably quite compelling advantages in terms of precision and accuracy and efficiency and all of those things, and weight, as I said at the beginning in particular. And yeah, we've been doing some embodied carbon analysis on some of our own activities and comparing it, and with LGS surprisingly good in that respect. Though I note, some of your comments about the work needed to be done to improve the picture and, create more widely available information for reporting purposes. It's clearly a work in progress there. I've got a general kind of question about market dynamics, which I'll ask in a minute, but a quick one first, if I may. On the pile caps, was that a timber cassette for the ground floor that you were building off as a starting point?
No, so at that point we worked through, trying to reduce the number of pile caps, increase the number of pile caps, and then see what kind of floor structure would work with the space in between them to come up with the most efficient solution. So we worked through that. In that case, we ended up with some hot rolled beams in places to create the wider cassette, and then light gauge joists spanning between them. So that allowed us to finish it both on top and underneath as well when we were transporting it to site. So we did quite a bit of analysis and engineered that solution to make it the most efficient possible.
I misread the colours on the drawings on the model there, but I understand how you eliminate the cold bridges on the walls, but how do you do that on a floor cassette then, where you've got steel meeting steel cap?
So we have quite a thick thermal break that sits between the beam itself and the cap. So with the way we design things, it gave us confidence in the ability to accurately position that on the bottom of the steel. On the rest of it, it's fully wrapped in insulation as well.
Okay. So the sort of load-bearing or insulating block in between the pile caps and the underside of the floor cassettes then?
Exactly.
Yeah, okay. Thanks. So the general question then was about the market dynamics in Ireland. There's a lot of timber frame. You're scaling up. What kind of market share do you have at the moment? Are you competing head to head with timber frame in Ireland?
I wouldn't say so, no, to be honest with you. Like we do housing schemes, but generally, as I was saying, the sweet spot is apartment buildings and that. Now, look, we vary from 50, 60 apartment units to one-off houses in some situations. So it just depends, and it lends itself well to quite architectural houses where it's very hard to achieve spans, etc. So that from that end, you see it, and it's a nice challenge at times to get that as well, right the way through to apartment buildings. But we do plenty of houses as well. I wouldn't say that we're head to head with timber frame though at all, to be honest with you.
So today then was more of a left field example, not really representative of the kind of work you typically do then?
It's a good mix, like it is a good mix, and we do houses, as I was saying, but it's it just depends on the scheme and where it is, and also how people look at the program as well and just compare them, and there's a lot of different factors that come into play, and then some people just would prefer to go with light gauge steel frame in some situations.
Yeah. Great.
Paddy, I know that we've had quite a few questions come in, so this is where we hand back to Zach to do this little section.
Yeah, fantastic. Thank you, Ben and co-host and Paddy. So our first question comes from Eugene McMahon. So Eugene, can you come on screen and ask it?
Hi, Paddy. Hope you can hear me. Thank you very much for a very interesting presentation. I'm from Ireland, as you can hear. I had a query. It was a comment that I had said to Sean St. Amour yesterday, actually, regarding the commercial price of in the way materials are escalating here in Ireland. And a recent report, a media report in the national newspapers about a week ago, said that timber frame was currently running at about 64% cost increase, and metal frames, metal systems were about 30% roughly. So that makes your system very attractive. And just listening to the other speakers, I'm just wondering, Sean's point was that, okay, in any economic assessment of this thing, you have to consider the additional insulation thicknesses required. So he said there's trade-offs to be made there. So maybe you can comment upon that. And then I had another query, just a short query was, are these LGS profiles, are they very similar to the SFS profiles that we use here in Ireland? I'm sure you're familiar with them. Okay, so that's my 2 points. Thank you.
No problem. Thanks for the question, Eugene. So I won't lie to you, I'm not overly familiar with the amount of insulation that is going on to timber frame. Hugh might be able to give me a bit of a guide on that, but I think it's, yeah, I don't want to hazard a guess on, just to compare them. No, sorry, Eugene, I don't mean to be.
That's okay.
Yeah, just in terms of even complying with regulations here. But yeah, and look, the price of everything is going up at the moment. Still, you know, the things will come back hopefully eventually or settle down. But yeah, we're just, yeah, as I was saying, we'll always come up with the most efficient solution for the U values requested. But I wouldn't say there's anything untoward required outside of our steel frame to achieve you know, regulatory U values anyway. It's not like you're going to end up with a huge insulation buildup. The second part of your question, Eugene, was the, sorry, I'm after
the profiles themselves. You know, are they very thin or flexible, bendy, or are they rigid, or what way are they? You know.
So it is similar to SFS, but so we have 2 roll machines here, so we can roll numerous profile sizes from 75 to 100, 150, 200, and 250. And we can roll those at gauges of 1, 1.2 mil, 1.5 mil, and 2 mil. So as we were saying earlier, we'll engineer the solution to suit and ensure that we get the leanest design possible. And then that's what we based on. But you'll see a mix of profiles and gauges throughout any building to ensure that we're getting, you know, we're getting the most efficient solution we can.
Yeah, I would imagine it's determined by where you are in the structure and the load take.
Exactly.
Yeah, I understand. Okay, very interesting. Thank you so much, Paddy. Very, very
Thanks,
good.
Eugene.
Bye.
Thanks, Eugene. So we have some more questions, but we're also getting close to the end of the first hour, and we know that some of the audience will need to probably take off at that point. So we're going to start to close up the first hour, and then we'll continue in the second hour with, or at least a few minutes into the second hour with more questions. So co-host, do you want to say a couple words?
Yeah, just before we segue into overtime, and for those who are leaving, just want to thank Paddy for a very informative presentation, and wish everyone a good afternoon.
Yeah, and very similar comments from me, Paddy. Thank you very much. That certainly filled me in on a build methodology that I'm not that familiar with, so appreciate all of that.
Yeah, not a great deal more or different to add, but yeah, it's really open sharing of information, Paddy, and we appreciate the detail and understanding that everyone kind of gets from that. So back to you, Zach, I guess.
Thanks again to Hugh Wariski and Yulia Potor for creating the Building Performance Interactive. And that closes off the first hour. So now we're going to go into overtime with some more questions. And the next person on the queue is, sorry, I've lost my queue a little bit, is Ken Neuhauser.
Hey there, thank you, Zach. And
yeah, thanks, Ken.
Thank you, Paddy. I enjoyed and found the presentation very informative, so thank you. My question is about the control layers in your assemblies. They went by a bit quick for me, and I was wondering if you could either show us or explain where you have your air barrier and your water control layer within the assembly for the roof, wall, and floor.
Okay, so just on the roof itself, our air barrier would have been let's say, just taking the Leitrim Village project as an example. So the air barrier or the air tightness layer would have been the isoperm that we used in the roof, and that's sandwiched between the insulation and the steel frame itself, the steel frame rafter. And then from a vapor control or a weather perspective, we have the exoperm sitting outside of our insulation layer underneath the roof sheeting. So that's where that would be on the on the roof. And then in terms of the walls, so we have a Cineash weather defense board that acts as an air tightness layer on the inside. And so that's clad on the steel frame on the internal face. And then on the outside, we have the Exoperm 150 again, which gives us the weather tight seal. I hope that answers the question. I'm not sure if there was any more you needed on that, Ken.
Oh, yeah, I think that just about covers it. And then I can imagine how you connect those air barriers at the roof to wall, because they're in the same plane. Exactly.
The air tightness layer it wraps around underneath the roof and down onto the internal face of the wall, which works well, and it's all within inside the external insulation envelope. So it works well. And I could imagine it's similar with the floor. Exactly. Sorry, touch the floor. The floors in Leitrim. So we had the Exoperm 150. We worked through that with Partel at the time just to get the right product for that. So that wraps around, and again, it comes up and ties in with the board in the building.
Beautiful. Thank you.
No problem.
Great. Thank you, Ken. So up next, we have Lloyd Alter.
Hi there. Can you hear me?
Yes.
Yeah.
Yeah, great. I have a question. You know, just when you were showing the A-frame design, I was looking up the definition of lean manufacturing as a production process based on an ideology of maximizing productivity while simultaneously minimizing waste. And you're building an A-frame, which is the least efficient design in the entire world in terms of an closing space with difficult connections of floor to angled walls. It seems to totally contradict the idea of lean design, to be putting all this effort into a form that encloses the least amount of area for the shape.
No, well, look, that's I'm not too sure on whether they were considering the whole lean process from a design perspective. So we actually have no influence on the building design, the actual architectural shape of the building. So that's something the client came to us with, and that's something we put through our own process to make it as lean as possible from a manufacturing perspective.
Thank you.
Zach, well, we've got Lloyd there. I just wondered whether he had any book recommendations at all.
That sounds familiar somehow. And we will include a link to the video of Lloyd's recent appearance speaking about the book, which was one of our most popular events.
And I see a great answer to the problem there. The walls are leaning inward.
A whole different take on lean manufacturing. Okay. All right. So up next is John Flynn. John,
hi, how's it going?
Hey, John, how are you?
Not too bad, not too bad. No, it was just generally a question about procurement. So I was just wondering, in terms of deposits down, like what's required to kind of initiate the process? Like there's reports of companies looking for as much as 50 and as little as say 30%. And I'm just wondering, in Paddy's experience, is that around correct? Or
look, it can vary from project to project, John, and just depending on the scale of the project, etc. as well. Obviously, with offsite manufacturing, there's a big upfront procurement process from our end, so that's probably how it all ties in, but it's not something I'm actually too involved in from a commercial perspective. So, but you're probably in the right ballpark, I'd imagine.
Thanks.
Sorry to give you a short answer.
Yeah, no worries. Thank you. No, I suppose I just wanted to know if it was an outlier. Like I kind of know from some of the projects I've been involved with, that's kind of what we're talking about, but I haven't done LGS or CFS. It's kind of been timber frame solutions, modular, or yeah.
Yeah, no, it's a fair point though, and it probably is right-ish anyway.
Okay.
All right.
Thanks.
Thanks, John.
Great, thanks, John. The next question is from Joseph Connolly, but it looks like Joseph isn't able to talk. So I'm going to ask the question for him, and that is there a conflict between cavity barriers and insulation requirements? Question mark. Bridging point?
So, I think he's probably referring to cavity barriers for a multi-story building. I'm going to answer on the basis that is talking about anyway. So with the way we do this system is we create like a residual cavity behind the external insulation layer. So it's a non-vented cavity and the cavity barrier sits within there. So that means that the thermal envelope is never broken. I hope that makes sense and answers the question. I think that's what he was getting at anyway.
Great. I think so far so good. No news is good news, I think, from Joseph. But Joseph, if you have another question or follow-up, please type it into chat. I think that does it for questions, unless there are any others that people haven't yet posed. So if so, unmute yourself and go ahead and ask it. Otherwise, I think we'll wrap up. Joseph says sometimes you have to break insulation.
Not really. I don't know. Yeah, well, the only other way, if we did ever have to break it, is we'd end up using a non-combustible insulation rather than a cavity barrier itself. But that'd just be in a vertical scenario where you wouldn't be, say, blocking a cavity as such. So that's kind of, that would be the answer to that, I think. I'm just, yeah. I'm not sure if I'm interpreting this, so sorry.
No, it's good. Thanks, Paddy. All right. Well, I think that does it. Any final words that you'd like to add, Paddy, or the co-host would like to add before we close it up?
From my side, anyway, I'd just like to thank everyone involved, including yourself, Zach, Hugh, Ben, Adam, Smith, and Mike, just for allowing me to take part. And it's been a great experience. So I hope everyone learned a bit, and from a like-age deal perspective. And yeah, thanks again anyway, and I really appreciate the opportunity.
Absolutely, Paddy. It was super interesting and really great work. So thanks for sharing it with all of us.
Thanks.
Anything else? All right. I think we're good. Well, that was fantastic. Thanks everybody for joining us today. And please join us next month for episode 8, which I think is the final episode of the Building Performance Interactive series, at least the first season. Maybe we'll need to beg Hugh and Yulia for a season 2. But enjoy your Thursday, and we'll see you next time.